So questions for one of these presenters for the PowerPoint presentation. Tell me your name and for who do you have a question? Go ahead.
My name is Stefan Hansen. I'm from the Czech University of Denmark. I have a question a little bit to Vyvyan. I think it goes on to Mercy. You said, Vyvyan, that industry are the ones that are pushing this technology, and I find that somewhat strange with nanotechnology. Actually, if you look at the early funding of it in the 2001, and it was actually government that started funding this in Europe, in Japan, and industry wasn't really on board. And that's actually been a problem until 2007 and 2008, that industry wasn't really picking up on the research that was coming out of these research institutions. I think actually in this case, governments are a little bit to blame that they didn't put off 10% of all the funding to go into risk research and to public dialogue. And had they done so, we might not have the problems that Mercy are addressing. So yeah. I was wondering if you could comment on that, and then maybe Mercy could pick up on like what could governments do in the future.
Well, firstly, it's nice to meet you. We've been writing a report for WHO together for the last 2 years. I guess what I'm trying to say is once investment has gone in, investors want to see a return on their money. So yes, I mean, I do take your point. The government has been very proactive in developing this technology. But now big industry is involved, and then there is another pressure to develop. We should be spending more, I think, on safety investigation. Having said that, I mean, under the framework 7, there was 1.6 billion euros for nano. But as you say, a lot of that was for development. I think only 10% of it was. Every application had to have a safety aspect to it. That was one of the stipulations. So they were aware of it. In a way, I think it's a bit of a success story in that because of this pre-existing database on aerosols and pollution and ill health, the regulators have got onto it much sooner than they did with some other aspects in the past. So it's a bit of both, really. But now I think we need to make sure we've got our regulatory test things before we allow this to go much further. Otherwise, you know, we may end up with a problem.
Yeah. Other more questions?
Someone else wants to say something to that?
Me too. Yeah, I think I agree with you that the government played a part in, you know, getting it going and rolling. But I think the thing has been, it's the scientists themselves who pressured the government, because my understanding of it is that, you know, after the biotech bumble, so to speak, scientists found themselves in a situation where they couldn't attract funding and they couldn't find an excuse for how they could brand and sell their ideas so that the government could increase funding. And there was competition between molecular biologists and physicists, and part of it is the game where they managed to actually come up with a nano buzzword. It's a hype, it's a brand, where they were actually branding the kind of research they do. In fact, when you talk to most of the scientists, they were telling us openly, you know, most of the things we are doing and we are branding nano, it's things we used to do before. I mean, like some of the people doing the hydrogen, you know, research, hydrogen conversion and fuel cell, the catalysts, they were saying, you know, these things we've been doing our whole life, but now we are calling it nano. Next time we're going to call it something else. And many of the scientists who are actually doing microbiology or you know, engineering, they were openly telling us, like, listen, the things we are doing, it's things we used to do before, but now we are branding it nano. So it's kind of a brand, and they managed to convince government, but also industry, to actually go that road and that trajectory. So I guess in the future it has, but that also goes towards the whole science and research policies in the EU, but also internationally, where scientists are being forced actually to overpromise things that, you know, they can't even be able to promise, and they're under pressure to say what are the benefits of their research to the society. So they're under enormous pressure. They don't feel that they have to I think it has a lot to do with the demands and the expectation the society and the governments are putting on scientists, and then putting them in a situation where they almost have to lie about what they're doing, really. And I guess it's something to do with the science policy at the EU level, but also nationally. The government should, give scientists more freedom to do, more independent research and to do more free research, instead of always having to argue what's the social benefit. One of the scientists was telling us, when we make these EU proposals, we almost have to say what we're gonna deliver, and if we're gonna tell them what we're gonna deliver, then we shouldn't do that science in the first place. So it's all these policy pressure and research funding pressure that is taking us where we are. So maybe we need to have more balance, where scientists are given enough money and freedom to actually follow their ideas and things that are interesting and important, and maybe what they're good at, instead of spending all their time with branding and employing communication experts.
I would like to comment on the German case here. For here it is very clear that our government pushes the marketing and development of the products precisely. And although my Umsicht project that I presented before, and the one with the industry and the regulation, is paid by this government, the so-called Ministry for Education and Research, I call them Ministry of Economy number 2, for it is really true. They have a huge nano initiative. And one day, last year, I was searching for one of the other projects within the program Vyvyan on the website of the ministry, and I just couldn't find it. And then I couldn't find my own project financed by them, and I couldn't believe it. The whole ministry ignores completely the whole risk research. They do marketing, and I know with this marketing they hide away the risks underneath the table, more or less, and promote the potential advantages. And then I was so upset that I couldn't find it, and I sent an email to the whole mail distribution list. Can this be true? They are paying us and are completely ignoring us on their website. And I mailed it, including representatives of the ministry themselves. The only reply I got was, "I'm afraid you're damned right." So that's it.
Can I just say one thing? You also have to consider, under who sets the agenda of the research money that is put in that was pushed by the governments. Obviously, on the first base we have innovation, which is important because we, especially as there's a financial crisis behind every corner, that they want to push for innovation. But that doesn't mean that this should translate automatically into marketing what has been researched for. So the mechanism should be try to have a pre-market surveillance before these products get on the market, which didn't happen for nanomaterials. And then there's another issue, just going into the legislation, which there is a safety net, at least under REACH, because despite there is a lot of uncertainty, but the idea of a regulation like REACH is that whatever you put on the market, you as a manufacturer have to guarantee that what you put on the market is safe. It doesn't have adverse effects on the health and on the environment. Now, how this will translate in terms of liability if these mechanisms will be proved is still to see, and it's not at the level of a European institution, but rather probably at member states level. But this safety net probably needs to be more underlined as a responsibility of the companies that put these substances on the market.
Vito, thank you so much. How many questions do we have? Still, we have about 10 minutes. 2 over there.
It's my turn?
Yes.
All right. I think what we haven't addressed is that there is a game played between government promotion, scientists with their vested interests of getting project funding, and the private sector. So you don't have the private sector only, or government only, or scientists only. There is one game. But the game can be changed, because if government passes proactive regulation, if not only scientists in a pre-competitive, productive mode, but also in a safety mode do their research, and if companies are held liable for what they do, that is another triangle with a different game. So I think we shouldn't blame one of the actors only. Secondly, you do have a changed role of public research. People are still talking about the model of the 60s and 70s, when you basically, science was the only uncorrupted actor in a troubled universe. Now you have scientists who, for very good reasons, in fundraising, have to pretend that they solve one of the major problems of humanity, meaning hunger, obesity, cancer, HIV, Alzheimer, etc., etc. And they do admit it if you talk to them. Now, we moved from this basic research model to a pre-competitive research model. And all of a sudden, governments and scientists and companies behave like the Austrian literature has the picture of the salad dog. A dog sees a group of dogs rushing to a bowl, it runs there and outcompetes the other dogs, reaches the bowl and eats the salad, although dogs normally don't like salad. So the competitive model takes over the mind frame so much that you don't look whether there is salad in the bowl if you're a dog.
Thank you. Dr. Juliane, you have a question?
My question is, have you considered within the framework of the risk assessment for nanoparticles the problem of coherence in matter? For nanostructures in living organisms, there is the problem of coherence. The first paper in this matter was by Penrose and Hameroff in 1996. They wrote a paper where they indicate that the microtubules of actin could create the consciousness. And Penrose is a famous physicist. So the problem is that in nature, microparticles are coordinated by coherence, by electromagnetic fields. There are not in nature nanoparticles without electromagnetic fields. Only artificial nanoparticles are set up without electromagnetic field. It could be a crucial point for the risk assessment.
What I do know is that these particles are completely novel. And my watchword in these things is, if we've been exposed to something throughout our evolutionary history, there's a fighting chance that we're adapted in some way to cope with it. So we see that with heavy metals. I mean, there's always been heavy metals in the environment. We have carrier proteins to cope with them. But you only have to put them up a little bit, and then suddenly the system doesn't work anymore. So, but these engineered nanoparticles we have not really been exposed to in previous history. Natural dusts such as earth and sand and things like that, much bigger. So we don't know an awful lot about the question you asked. I think there's a wall of ignorance. Certainly we've just done some research looking at the effect of radiation on matter as you make it into smaller and smaller particles. And you do start to produce many more photoelectrons for a given dose of radiation if you make it into many, many small particles and a given mass of matter. And that may well have an effect in itself. But as I say, these are only preliminary thoughts, and we know very little about what you asked.
So maybe it is possible.
Sorry. Sorry if I correct you, but natural dusts are at the nanoparticular scale. So clays can be that small, or also from incineration products, so from burning, etc. You will get will get a whole range, but what you will not get in natural nanoparticles, there will always be a very broad distribution of size classes. And what we have here in the natural nanoparticles is a very narrow distribution of one size class. And this is one of the concepts I want to follow in the future, if this uniformity in itself may pose a risk.
Yeah, okay, so I should just qualify what I said. I mean, I think man harnessed fire about 200,000 years ago.
Yeah.
So that's quite recent, really. I agree that you get nanoparticles from combustion, no question. And salt, from suspended marine aerosol, you get nanoparticles of salt.
And from
clay. Yeah. Okay. Yeah. But insoluble metal particles, no, they are new. Yeah.